Let's finish up concept 53.6 in chapter 53 with the talk about the human population. It's difficult to talk about population dynamics and all of the various biological population related things without talking about the human population, which has seen a huge explosion and exponential growth basically for the last few hundred years. So we can kind of relate some of these biological concepts back to us. Of course, the vast majority of all the concepts we've discussed this year directly relate to human beings as well. There's only a few cases where humans depart from, say, the rest of the natural world when we talk about biology, and we'll talk about a few of those here where we do kind of separate or depart from the rest of the biological world, and of course the vast majority of it where we fit right in and follow along with the same rules that the rest of biology follows. So concept 53.6 says the human population is no longer growing exponentially, but it's still increasing rapidly. There was a point in the very near past, the not too distant past, where you could say the human population was growing exponentially. It has begun to level off slightly, but is still growing at a huge, enormous rate, and we're going to talk about how have we sustained that exponential and then now almost exponential growth for a long period of time. No population can grow indefinitely, and humans are no exception, but there are some unique things about humans that have allowed our population to grow quite a bit more than you would expect in the rest of the natural world. Here's a quick little link here. It's kind of funny. If you click here, what do you think the amount of space is if you took every human being on Earth and just put them into a large pile? How much space would they take up? Would it fill a portion of the Grand Canyon? Would it fill all of the Grand Canyon? What if you took all the human beings who've ever lived? How much space would they take up? Kind of a funny little interesting article that is right there on Gizmodo if you want to click on that and take a look. All over the internet you can find all sorts of good human population growth charts to take a look at. This one is just kind of a mixture of a chart and a cartoon showing the human population growth including projections up into about 2050, and it talks about how there has been exponential growth from about 1650 basically almost into the present time. So as you can see, for many hundreds of years human population growth was fairly slow, fairly steady. It was growing, but at a very slow and steady rate. And then about the mid 1600s, the population began to take off and grew at an exponential rate until very recently, and only now is slightly below an exponential rate. Here's another good example right here. You can see even some very interesting things, like in the textbook it talks about this little dip right here, which was the plague, the Black Death in Europe that wiped out hundreds and thousands of people, and so that's that little dip right there. But then you can see this enormous growth rate, this exponential curve up into the modern era. Right now the global population stands at a little over 7 billion people. Down here at the bottom of the page is a link if you want to click on and get a good estimate of the most accurate, up-to-date numbers. This little meter here is constantly spinning and changing, continuing to rise. So right now there's about 7 billion people, and if you want to check out the current world population, just click right there. No other large animal has ever sustained such a growth for so long of a period of time, and that's because of some unique things about the human species. Though the global population is still growing, the rate of that growth has finally begun to slow down since about the 1960s. So currently you wouldn't say, well, we're still at exponential growth, but we are still very close. So here if we look at an annual percent increase, you can see that this is as the rate basically we're talking about. You can see the rate is beginning to decline since about the 1960s. It has begun a decline and is predicted to continue to decline. Now, that doesn't mean that our population is not growing. It just means that it's not growing as quickly as it was in years past. All of that data was a global population, and of course not everyone around the globe experiences the same population dynamics. So when we look at the global scale, those are the charts that we were just looking at, but regional dynamics vary widely around the globe. You have some areas that you consider industrialized, more modern countries, and then you have some that are not quite as modern as, say, the United States, or not quite as developed as the United States, and so you have various dynamics in different parts of the world. To maintain population stability, a regional human population can exist in one of two configurations, and either one of these would still be considered stable, but you can see where they would not be the same. So you can have zero population growth with a high birth rate as well as a high death rate. So if you have a high birth rate and a high death rate, that could still be zero population growth, and that would still be a steady population. Compare that to another zero population growth area where you have a low birth rate and a low death rate. Now, so both of these populations are steady, but if you compare the two, they are not the same. You might find, say, in sub-Saharan Africa, the population growth rate is near zero. They have a high birth rate and a high death rate. Compare that to, say, someplace like the United States, where the population growth may be close to zero with a low birth rate but also a low death rate. The demographic transition is the move from the first state to the second state. And we kind of define whether or not a country is developed or not based on where they are in this transition. Do they have high birth and death rates, or do they have low birth and death rates? And that is kind of a transition point that kind of tells us a lot about that area or that region or that country. This demographic transition or shift from the high birth and death rate to a lower birth and death rate is also generally associated with an increase in the quality of health care and the general quality of life, improved access to education, especially for women. And we can look at different countries around the world, some that you would consider already developed, say like the United States or much of Europe, and then other countries, say in the Middle East or in Africa, and you can determine where are they in this transition point. For example, Sweden kind of hit that transition point in about 1960, where Mexico is estimated to hit that transition point in about 2050. So you might say that Sweden, as far as making this transition, is already more further developed than Mexico is. Mexico would be considered a developing country moving in this direction. And then of course you could compare that to other areas around the world and see the difference. Even though these areas still may both have stable populations or zero population growth, you can see the differences between the two. Most of the current global population growth is concentrated in developing countries. In the developed countries like the countries of Europe, the United States, say Italy, France, Great Britain, population growth has slowed dramatically and in some cases is even negative. While death rates in developing countries around the world have fallen quite a bit since the 1950s, birth rates have still been quite a bit more variable. So you could say that in all but the poorest countries around the world, death rates have fallen dramatically since the 50s, but in some of these countries, birth rates are still pretty high or quite a bit more variable. When you're looking at human population dynamics, one of the important things to look at is what's called the age structure. And the age structure is basically the relative number of individuals of each age. How many young people, middle-aged people, and old people do you have at any particular given moment? And so we look at that kind of in a pyramid-shaped chart, and it looks something like this. So you have a rapid growth population would be like Afghanistan, where you have a large percentage of your population that is very young, and you see it tapering off toward the older generations. And then you have a slow growth country like the United States, to where we have almost, except for the top when the older ages get and you start to have death rates increase, you almost have kind of a straight up and down column. You don't have this pyramid shape, you kind of have this more straight up and down column. Of course, you would expect it to taper off toward the older ages as people begin to die off. You do see this little bump, this lump here. Right now, this would be as of 2009, so this is already a few years old. This would be the baby boom generation. This would be basically a little bit older than me and my parents' age. So like I would be somewhere in this area here, right underneath this bump, and then you have this bump here that would basically be the generation slightly before me, the baby boom generation. Then compare that to the no growth rate countries of like Italy, which actually have no growth or they have negative growth, and you see they have the taper down at the bottom as well, where you would not really expect to see the taper. You'd always expect to see it at the top where old age kicks in, but here they have a bulge toward the middle, and since say about 30 years ago, obviously their growth rate has tapered off quite a bit to where they have fewer kids, fewer young people toward the bottom end of their population. These age structure diagrams can help politicians and sociologists and demographers quite a bit. They can help predict a population's growth trends and some other aspects of that country as well. They can also help illuminate different social conditions and political aspects. So think, for example, here in the United States about the various political and social issues that surround like Social Security and Medicare, and what issues can you see arising based on the age structure of some of these various countries. So for example, when you look at say the United States and you see this slight bulge, eventually these people are going to be older and older, and they're going to be supported by fewer people below, especially in a country like Italy, where you have fewer and fewer people down at the bottom, and they have various social safety networks, like probably they have a version of Social Security or retirement, and there's not as many people that will be of the working age to support this larger population that has retired. So it's not just biology where this comes into play, it's also politics and sociology and social aspects as well. The other thing that demographers look at when they're looking at human populations in particular and comparing different regions or countries is the infant mortality and life expectancy rates. Infant mortality and life expectancy at birth vary greatly among developed and developing countries, but don't really capture the wide range of human conditions. So while this is one important fact to look at, it's not the only thing that kind of helps define a particular country. But you would expect in a more developed country that the infant mortality rate would be lower and the life expectancy would be higher than in a less developed country. So for example, if you look at infant mortality rate, which is the number of deaths per 1,000 births, in industrialized countries it's well below 10. In less industrialized countries it's quite a bit higher, the mortality of infants. And then if you look at the life expectancy, again you kind of see the reverse, where in industrialized countries it tends to be longer, higher, and in less industrialized countries it tends to be lower, shorter. Finally, we get to this question of the global carrying capacity. We've talked about carrying capacity of various environments for other animals, but what about the United States, or not just our country, but the entire world, the entire globe? Right now there's over 7 billion people on the planet. How many people can the world sustain? What is the number that we would hit before we would begin to have major problems? And it's interesting to study, or interesting to look at, because the only reason that we have reached 7 billion is because of the fact that we can modify our environment. If we didn't have the ability to modify our environment, we would have never reached this number of 7 billion. We would have never seen that huge exponential growth that we saw on the curve a little bit earlier. Population ecologists predict a global population of anywhere from 7.8 to 10.8 billion people by the year 2050. And the question is, how high can that number go? Without agriculture and medicine and all of the ways that we have already changed our environment, it would have never made it to 7 billion. There's a lot of different estimates. If we just lived in the natural world the way hunter and gatherer societies did, early humans, that we would have never reached the number that we've already reached. But due to our advanced intelligence and the ability to modify our planet, we have increased its carrying capacity. The big question is, how much more can we increase that carrying capacity? So that number is kind of a mystery. The estimates range anywhere from 10 to 15 billion, all the way up to, I've seen numbers as high as 20, 25 billion. It really depends on what we do to change our world, much like we've already changed it to increase its carrying capacity. It's a big question. If we do continue to do things as we do right now, we may be in trouble, because humans, especially in certain developed countries like the United States and Europe, use copious amounts of energy and inputs, far more than other countries. And if we continue to do this, we may start to have a problem unless we make some dramatic changes in the resource management of our world. 10 to 15 billion people may start to reach carrying capacity, and when we start to have those types of problems, you're going to have various social problems as well, political problems, war, and those types of things are going to increase because of the various pressures, just the various biological and natural pressures of reaching carrying capacity. Quick little link here if you want to get some more information about the Earth's carrying capacity. This was an interesting article on how stuff works, about the potential for hitting that carrying capacity of our planet. One way to look at the limits of human population size is to look at what we call the ecological footprint, and this idea summarizes the aggregate land, water area needed to sustain the people of a nation, and it's kind of one measure of how close we are to the carrying capacity of the Earth. And I already said that countries vary pretty widely in their footprint size and available ecological capacity. If we look at a map here, you can see that not everyone around the world uses the same amount of resources per person. When you look at the more developed countries, particularly say the United States, Canada, Europe, you can see that there are some places around the world that per capita, per person, energy use is tremendous, and energy use is going to relate to resource use. So you can see the United States by far, and then Canada, and then Europe and Russia and Australia, the more developed areas of the world tend to use huge amounts of energy, and contrast that with, say, South America or Africa, where energy use is quite a bit lower. Now, you would also say that probably quality of life and life expectancy is also lower in these areas, but certainly it's probably wise if we consider ways to sort of balance this out a little bit, to where some people get more and perhaps other people use a little bit less, if we want to continue to increase the carrying capacity of our planet. So in the future, I mean, there is the idea that we could reach this carrying capacity, because there is not unlimited food, space, non-renewable resources, buildup of waste, all those same things that we talked about that keep the E. coli population in check, or the moose population in check. Some of those same factors affect human populations as well. Now, the difference, the thing that sets us apart from, say, the wolf or the E. coli, is our ability to modify our own environment, and that has already allowed us this exponential growth. It has allowed us to increase the carrying capacity of our planet, give us a longer life expectancy, greater quality of life, and so unlike other organisms, we can make changes. That also means we can regulate our own population growth through social changes. So we have the ability to not only increase the carrying capacity for humans of our planet, but also to reduce the number or the density of our population to better benefit all the existing humans already on the planet. So we have the knowledge and the ability to make this difference, unlike lots of other animals on the planet, but do we have the will? Do we have the ability to follow through and do this? Well, that's a question that maybe doesn't belong in biology class, perhaps belongs in a political science class or sociology class. We're going to stop right there. A very interesting topic about population dynamics. If you have any questions, just let me know, and I'll see you online. Have a good day. Bye.